Hi students, in our last session we have already dealt with the basic concepts of computer security and its architecture. As we have already learned, the OSS security architecture can be categorized into three parts. The first one is the security attacks, the other is security mechanism, and last the security services. In our last class we have dealt in detail about the security attacks. In this session we will be dealing with the security services and the security mechanisms. So to start with, let me start about the security services. As per ITU is nothing but the International Telecommunication Union. X.800 is a standard recommendation for the security architecture. And so X.800 services or the security services can be defined as any service that is provided by the protocol layer of the communicating systems. Okay. Now, as per X.800, the security services are divided into 5 categories and 14 specific services. Let's see what the categories are. The main 5 categories are authentication, access control, data confidentiality, data integrity, and non-repudiation. First one is the authentication. We have already dealt with this topic. What is authentication? Authentication is the assurance that the communicating entity is the person or the one who he claims to be. I say I am a person, for example, I am Ram, and at the other end, the destination can verify that I am exactly the person I am claiming. So that is called as authentication. So in two sorts or in two aspects we have to measure this authentication. The first one is pure entity, that is in the confidence of the identity of the communicating entity. So we are verifying the identity of the entity who is being communicating, that is pure entity. The second aspect is the data origin. We have to verify, or we should be verifying the source of the data that is being transmitted in the communication channel. So the source must also be verified, and that aspect comes under data origin. So the first category is authentication. The second category is access control. We have already dealt with this. Access control is nothing but everyone have no access to every files in an organization or every folders or every system. So there are specific access rights. Some are denied, some are given. So this access control service mainly focuses on providing the access rights to the various people in the organization. What kind of data they can access, on what circumstances they can access, and what they can do with that data which they have access to. All these things are being dealt in this access control security service. The third category is data confidentiality. Confidentiality is nothing but protection from unauthorized disclosure of data. So the data must be not disclosed to any unauthorized user, and this is preserved in data confidentiality. Moving on to its specific services, here we are dealing with 4 specific services: connection confidentiality, connectionless confidentiality, selective field confidentiality, and traffic flow confidentiality. We have seen 2 terms, connection oriented and connectionless oriented confidentiality. When it comes to connection and connectionless, see, in a communication, the data is being transmitted as blocks of data. And if it's connection oriented, you say all the blocks of data in the connection is being preserved. If it's connectionless, you say they are not connected. So a single block of data must be preserved in whatever means we are talking about. Hope I am clear. I'll say once again, I'm dealing with connection confidentiality. Here, protection of all user data on the connection. So whatever comes in between the connection, all the user data is being protected here in connection confidentiality. The second specific service is connectionless confidentiality. Here the protection is given or to the user data in a single block of data. So it's not being connected. So in a single block of data, all the user data is being protected. The third one is selective field confidentiality. For example, the teacher's login, teacher's details are being collected in our office, and you don't want to expose the date of birth and the phone number to everyone who sees the details. So I can, if I want, I can hide these two specific fields. So some selective fields are being protected for whatever purpose. If it's confidentiality, it's disclosure. For modification, it's the other side, integrity. It depends. So selective field confidentiality is nothing but protecting the selected fields, okay, whether it is in a connection or in a connectionless communication. So if it's in a connection, you say the data is being the selected fields is being protected in the whole connection. And if it's connectionless, you can say the data is being protected in a single block of data. The specific fields or the selected fields are protected in a single block of data. The last specific service of data confidentiality is traffic flow confidentiality. What is traffic flow? What is traffic flow analysis? The third party or the opponent, that is the person in between the source and the destination who is trying to take the information between, he can try to access the information or obtain the information by observing the pattern. So why is he doing that? Because the data is being encrypted. It's not in readable form. So he is trying to observe the pattern of the message that is being sent from source to destination. So in that case, the protection of data is that is focused on traffic flow confidentiality. So traffic flow confidentiality makes sure there's a protection of data that can be derived from the traffic analysis. So the pattern of the messages is being kept safe. The fourth important category is data integrity. You know what is integrity? Integrity means the message or the data that is received at the destination should be the same as it has been sent from the sender side or from the source side. There should be no modification, no insertion, no deletion, or no replay attacks. So no delay of messages. So that ensures data integrity. Let's see the specific services. Connection integrity with recovery, connection integrity without recovery, selective field connection integrity. Let me talk about first these three. These three come under connection oriented, and these two come here under connectionless communication. So in connection oriented, we are dealing with connection integrity with recovery and without recovery. Both actually functions as the same, but the main difference is that in connection integrity with recovery, the data's integrity is preserved, and if by chance any modification is found, it is being detected with recovery attempts. So you can recover the data also, and that provision is being provided in connection integrity with recovery. The other case, connection integrity without recovery, is the same definition which I said right now, but the only difference is that the data cannot be recovered. That is, the data's integrity will be preserved on a communication, but recovery is not there. Only detection, no recovery. The third one in connection oriented is selective field connection integrity. I have already said before, as here provides integrity for the selective fields on the connection. So exactly on certain particular fields on a connection, the data's integrity is being preserved. Moving on to the connectionless integrity, I have already said when you talk about connectionless, it means that a single block of data, so they are not connected. So here the integrity of the single block of data is being preserved. That is connectionless integrity. And if you say selective field in connectionless integrity, exactly or specifically you can point out certain selected fields on a single block of data. Okay, so these are the main specific services in data integrity. The last or the fifth main category of security service is non-repudiation. It's actually not a very familiar concept, but still, non-repudiation is nothing but protection against denial by one of the communicating entities of participating in the communication. A is sending some message to B and B denies, I didn't get the message. So in that case, we have a proof that this message was sent by origin A and this message is received by the destination B. and that service is called as non-repudiation. And I have already said, now the non-repudiation have two specific aspects: non-repudiation for the origin, non-repudiation for the destination. If it's for the origin, it's a proof that the message has been sent by a specific party. So I am proving the particular origin. And if I want to prove that the particular destination it is, that is non-repudiation destination, which specifies the proof that the message was received by the specific party. Our next topic is security mechanisms. This can also be called as X.800 security mechanism. Security mechanism is any process that is used to detect, prevent, or recover from a security attack. In general, security mechanisms are classified into two. One is a specific security mechanisms, the other is pervasive security mechanisms. As the term indicates, specific security mechanisms are applied on specific protocol layer. But in case of pervasive, it's not for any specific organization or any specific layer. It is general. So some general mechanisms can be comprised under the term pervasive, and some specific mechanisms can be termed in specific security mechanisms. Let's move on. The first one is encipherment. The most common security mechanism we use is encipherment. A message is being sent from the source to destination. So for tightening the security, the message can be encrypted or scrambled so that an opponent in between cannot read the message as it is. So a decryption is needed at the destination end to recover the message. This is encipherment. So this is actually a mathematical, or it uses a mathematical algorithm to find one or more secret keys to decrypt at the destination end. So the first specific mechanism can be encipherment. That is the common one. Second one is digital signature. What is digital signature? It's actually a data appending to a data unit that proves the source and identity. And this is actually very important and very useful in protecting our data against forgery. So this data or digital signature will prove that it is our data, or it's the identity is the same. So digital signature is the other mechanism. Here the data is appended to a data unit to protect the data's source and integrity, and to protect the data against forgery. The next one is access control. Yes, it's a very common mechanism. Here the different access rights are being given. The teachers in the same organization, or the working staff in the same organization, everyone doesn't have the same access right to many things. Some are denied, some are given. So these access rights is the same when it comes to security also. The different mechanisms give different access rights to the different users. Next one is data integrity. As we have already said, this mechanism provides the integrity of data being sent in a communication channel. When I say the data's integrity is preserved, there is only one meaning. There is no modification or no insertion or no deletion or anything, no manipulation on the data that is being sent from the source to destination. So that is data integrity. The next one is Authentication Exchange. This is nothing but ensures the identity of the communicating entities by some information exchange. So it can be some code or some secret key or something like that. That is the identity of the communicating entities are being ensured by exchanging some information. Maybe I give 1, 2, and the third code will be given by the destination side, just to assure it's the right one. The right person is sitting at the destination end. So some information exchange can also prove or ensure the identity of the communicating entities. That is Authentication Exchange. Next is traffic padding. When the term traffic flow, traffic analysis all comes, there's only one meaning. The opponent is trying to obtain the pattern of message that is being sent from the source to destination. So the message is encrypted or scrambled, and he's trying to obtain the pattern from it. In that case, there is one technique or one security mechanism which can be used is you can insert bits into the gaps of the data stream so that you can frustrate the opponent, so that you can frustrate the third party or hacker, whoever it is, you can say. So you can frustrate him by inserting more bits into the gaps of the data stream. So he may get confused about the pattern of the message that is being sent. That is traffic padding. The next one is routing control. Some pronounce it as routing, some pronounce it routing, whatever it is. Routing control is nothing but, in some cases, some routes may be suspected, that is suspected of some security breach. In that case, I can select a alternative route for the information exchange. I'll repeat, that is, in some cases, some routes are suspected of security breach. In that case, we won't further go for that. We can use another or alternative route for sending messages from the source to destination. That is routing control. Notarization. Notarization is another security mechanism that is very specific and very important. I have been saying a third party opponent and all, but there is a case of trusted third party. Trusted third parties are used in some cases for information exchange. So it can be like some authorized person or authorized organization or something. That's a trusted third party usage. Okay, in case you use a trusted third party mechanism, that is actually called as notarization. The second category of security mechanism is pervasive. Pervasive, as the term indicates, it is not specific, it's actually general. So these 5 points in this pervasive security mechanisms are actually general, and it depends, or it can vary from one organization's security policy to another. The first one is trusted functionality. It's very, very general. That is, different organizations may have different security policies, and while using their security policy, if they say, yeah, this functionality can be trusted and used for security check, yes, that is a trusted functionality. So it can vary, but that may be not the case with another organization. So it can vary. So first one is trusted functionality. That is nothing but based on the security policy of an organization, the functionalities may prove right. And if so, we can call it as a trusted functionality. The second point is security label. Label is what? A name or a mark or something like, yes, the same here. It's a marking bound to the product or to the organization that marks its security, some sort of mark or something that marks its security. Yeah, I say if you have this mark or if they have this label, yeah, this is security done. The security is done with this organization. You can say something like that. So that is security label. Event detection. It's nothing but detecting all the security related events. Whatever events are connected with security can be clubbed together in event detection. Of course, it is general and it will vary for one organization and another. The next one is security audit trail. What is auditing? You need a record and you are checking the records. So same here, security audit trail means it's collecting all the data that is required for the security audit. So for security audit purpose, you are collecting so much of data. Security recovery, yeah, very important and very, very important topic actually, or very important mechanism in pervasive one, because loss of data, we cannot, every organization cannot tolerate it, right? Now, like the loss of data cannot be tolerated above so much percentage. If so much loss of data occurs, that is actually a big system failure, right? In that case, the data must be able to be recovered. So some recovery strategies can be used. So for that you have event handling or some management functions that support recovery. So for recovery purpose, whatever provisions we are using come under this title, security recovery. Our next topic is model for network security. So there is a general model for implementing our network security. This is that you have the sender side here on the left hand side and the receiver or the recipient on the other side. In between there is an information channel, and here is the, you can say, the notarization being applied, that is the trusted third party. They can be the distributors or something, or the generators of the shared key, that's a secret key. They are the trusted third party, and also of course the opponent in between the transaction. At the sender side, the message is being transformed or scrambled, or you can say encrypted to some secure form. So the message now became secure message. Now secret info is anything like the shared key or the secret key, what we say. And now the message is now formed or transformed to secure message format. It now passes through the information channel and reaches the recipient end. Here the secure message is then decrypted using the same secret information, and the message is retrieved. Okay, so this process is very simple. You have two ends or two parties, the sender and the recipient or the receiver, and the trusted third party, the information channel in between, and also of course the opponent will be there. The message is transformed to some secure form using the secret key, and the secure message at the other end is decrypted using the secret key, and thus the message is retrieved. So this is the basic model for any network system. Now any technique or all the techniques that helps in implementing security has mainly two components. The first one is a security related transformation of information that is being sent. Example, encryption. A wants to send some data to B, and A, if the message is really confidential and very important, he will try to encrypt it. He will try to change the format of the data so that in case any opponent comes in between, he will not be able to retrieve the information. So that is it. That is security related transformation of information that is being sent. Best example is encryption. The other ones, the scrambling of message and all. The second component is the secret information that is being shared between the two parties, the secret key or the secret information. So these two important components are the main part of all the techniques that implement security. So main two components. Finally, this model for network security actually does four big tasks. The main tasks are, the first one is you have to design an algorithm. Design an algorithm for what you said before, a security related transformation. So you have to design an algorithm for such a security related transformation. That is the first task. The second one is you have to generate a secret key that is to be used in this algorithm. So the algorithm is now being designed, first task. Next point is some secret key is to be used in this algorithm. You have to generate it. That is the second task. Third task is the secret key must be distributed and shared among the parties safely, right? The distribution is a very complicated task because it should be distributed or shared very safely. That's the third task. And the last task is you have to specify a protocol that is to be used by both the parties. That is a common protocol. The sender following a particular protocol, the receiver following a different protocol, that is not applicable in case of communication. So both the parties are supposed to share or supposed to follow a specific protocol, and that is the fourth task in this model for network security. So let me just conclude. This is the main model for network security. Here we have the sender side, the recipient side. Here the message from the sender side is being encrypted and sent over the information channel, and the encrypted form is received at the receiver end. The receiver then decrypts the data, to retrieve the message. In between you have the trusted third party and the opponent. The main two components of all the techniques is, the first one is a security related transformation, that is encryption. Second one is the use of a shared key, a secret key. The main task done by this model is, first one, design an algorithm for transformation. Second one, generate a secret key to be used in this algorithm. Third one, distribute the secret key or the shared key safely among the parties. And the last one is to specify a protocol that is to be used in common for both the parties. That's all. Thank you.